Hi, I'm Alex from Alex's Technic Creations, part of my channel where I show off my latest Technic stuff. So this right here is the beast that I have created. This is the bottom. It is geared 15 to 1. It's meant to pull things and I guess haul things. It's got a flat top right here, so you can put weights and stuff on it. And then you can see the bottom. I actually use 2 battery boxes, but you can't use both battery boxes at once. I learned that. So only one of them is being used electrically, but the other one has batteries in it, so weight, because the more weight, the better the traction. So, as you can see, the motor is actually mounted right here. It's right above this mechanism. You can almost see it in there. This is 1 to 5 right here. It has an 8 tooth going into the 40 tooth. Goes through this 1 to 1 and then 3 to 1. Now, one of the problems I've found is, for one, when you're making something like this, it needs to be sturdy. You've got to put like a bunch of stuff in structurally so that it doesn't just flex on you and just... So this thing I have put a lot of stuff into, and it's pretty sturdy. Now, sorry, I'm a little bit sick. Sinus infection. So, yes, so both motors are running, and I also had to, one of the problems, I guess, was the flex in this part. The axles and all of these parts are made out of plastic, so that's something you have to kind of work around. Like, so here's the play in the gears that you can't really do anything about. But then this is the play in the axles. You see how I'm twisting the wheels? Yeah, that's not doing anything here. So that's one of the problems. The force isn't. And there's actually a too long stud connector, axle connector in there. So that contributes a lot. But yeah, bit of a problem, but I'm not really sure how to fix it. And then I also have these wheels in the middle, which help. So instead of it being like a bridge, it's got like a support in the middle. That's a pretty good analogy. And then I have this top connected, and the IR receiver is right here. Now, it's test time. I have a chair that it can pull, and then I also have weights somewhere that it can also carry. So, we've got the carry and the pull test. Can you back up? So, right here, I've got this chair. Now, it's a tall chair. I've got the rope that I'm going to be using to carry it right here. And I also have like a mount for putting rope around right here in the back. As you can see, it can take a lot of weight. So, I take this, pull this top part off, and I can put the rope around this and wedge it back in there. Like so. Put this back on. This will work. Now, the thing the problem that I have is you have this and you can have it go, but as you see, it's not pulling it. And the reason that is because of traction. These wheels don't get very good traction, especially if there's like dust or something, and we have hardwood floors, so that collects dust really easily. So you have to add more weights, and I've got 2 5-pounds right here. As you can see, they're 5-pound weights. I put these on here, and these are for traction. Now that should hopefully increase the force of the wheels to the ground. So there you go. Now, usually you can tell by how, now obviously it's going to be really slow because it's 15 to 1. But it's taking it pretty easily. You can also tell how easy it is on the motors. You can tell how stretched the motors are. You hear this, and then if I pick it up, you see, so it's under some load. You can definitely tell that. Take the tension in the rope, and you can hear the motors, I wouldn't say struggling, but they're definitely under load. They're not free rolling. But if I am to take this off, put this back, take the weight off it. So this is just its rolling speed right here. Again, it's going to be slow. And if you want to see the gears running, here it is. As you see, motors are running opposite directions. The forces are changed, the direction is changed here, so they're running in the same direction. And the wheels run. So this is what the motors sound normally. And sometimes the location of the IR receiver isn't great. So sometimes it'll like cut out if it's in a weird position. Kind of like that. But as you can tell, it's pretty strong. Now, I did engineer this so that it's got a carrying top on it. One of the reasons is you gotta add weight for traction. So now here's the weight test. How much weight can it take? So I gotta be careful of the IR receiver, which is right here. That's important, but I can put these on like that, and then I've got, these are like 1 pound weights, maybe? I don't know, they're not labeled. Then I've got, here we go, 3 pound weights, right here. So 10, then we've got 13, 16, and these might be 2. Wait. Oh. Yeah, this is 2 pound, I'd say. It's hard to tell. So it's either 18 or 20 pounds with these on it. So you take 20 pounds. I weigh like 120, I think. Yeah. Yeah, somewhere around there. So this is like 6 times my, well, 1/6 of my body weight. And here we go. And it goes. Now you can probably hear by the sound, it's under a little bit more stress when it's carrying. And you can also see, I'll go back, you can also see the wheels flexing. Now, I've done everything I can to mitigate this, but I just can't. So that's, if I build something else, I'm probably going to use a different design. I can have my brother who's editing for me. He will, ooh, that's heavy. Yeah. I'll have him include a picture of the first design. Well, really, it's the third. This is the third design I've made. The first one had, I'll just have him show the picture of it. And that's when I had 2 M motors. And I was geared. I was geared a lot. It had the differential, which is like 1.4 to 1, and then 25 to 1 for the gear ratio. And it was a beast too. But that's with 2 M motors. This is 2 L motors. I also got the IR controller. So I'll have him put up a few pictures of that. And yeah. So, and my servo motor broke. So I guess I'm just kind of challenging myself for now. Oh, and if you hear the sound of it hitting the ground, I do have 2 of the 40-tooth gears, and it's flexing so much that they are scraping the ground a bit. But as you can tell, it still goes, which is pretty incredible. And if you've ever lifted 20 pounds, you can kind of tell how much this is going on, how much it can take. And if you want some real world comparison, just make sure everything's okay, and it is. It also has a open part in the center, which you could put, like, I don't know, metal weights in or something. So here's a bag of dog food. Now this is considerably lighter than the 20 pounds, but I mean, this is a full bag of dog food. I don't know. Oh, 6 pounds. 6 pounds of dog food. But here's dog food. Oh, and just hear the motors. They're going with it easily. Bam. Easy. Now, this cat litter, oh, that's basically empty. That's empty. Oh, 1 second. Now, this is water. Full gallon of water. It's about 8 pounds, a little bit over. But here's another comparison. Real world comparison. Man, I can't talk. And as you can tell, it takes it. So, I don't have any of the Mindstorm stuff. I wish I did, but if I had Mindstorms, I could program it so that I could go, you know, it could bring you stuff. I guess the ultimate Lego thing I would want to make is probably, it would be a car that would have a scissor lift on it, and you could program it to just bring you stuff. You could have a camera on it, on the center of it. You could have just an RC car, so you could drive it to where you wanted to go. Well, you could drive it, have something, put stuff on it, and then you could drive it back with the camera, so you know where you're going, and then you could just direct it back, and then you could hit the scissor lift, and it could, like, bring you, yeah, it could bring you, like, pop, a bottle of water, I mean, more Legos. Yeah, so this is what I've created. I think it's pretty cool, and you can see all the structural elements in here, all the beams supporting it. Went through a lot of pieces with this, but I think it's worth it. It's quite cool. So I'll give you one last look at it, and that will be it. So this is my latest creation, and thank you for watching. Like the video if you liked it, and if you really like it, sub. That'd help a lot. I'm trying to get to 10 subscribers by the end of the year. I don't know if it's very realistic or not, but I have 5 right now, so yeah, enjoy.